Swayam Prabha. Digital India. Educated India.
Hello and welcome back to the manufacturing automation course again. So, let me remind you that last time we have discussed the rotary centerboard hopper feeder, and in here the design, as we said, that there is a hopper and the edges of the blades which is rotating within the mass of the parts located at the base of the hopper. They are profiled to collect parts in the desired attitude and lift them clear of the bulk, later to slide off the blade. Now, what we said is that in these blades, the profiles are such that they, while moving through the mass of the parts, they will collect the parts which will be in the right orientation, because as you can see that parts shape is such that it cannot be located on the blade otherwise. So, then when the part is in this position and as the blade rotates from this position to the next position, the part will actually slide down the blade, and when the blade will be aligned to the delivery track, then from the blade the parts will be coming and they will be in the right orientation. So, this is the advantage of this feeder. And here is one example, like depending on the part that we have. For example, we have a part like this U-shaped part, and in this part we have the width W and this height is 1.5 W. We have the length here shown here, and this space inside where the blade will go, that is 0.52 W, and the width of the part is width of the wall of the part is 0.24 W. So, depending on that, we can actually design the blade, the thickness of the blade, the thickness of the space through which it will be going within the feeder in this way as it is shown. For example, the blade width could be 0.38 and the width of the part. Okay. And this is the hopper, which is the blade. This space within which the blade will be coming along with the part, this will be 1.13 W, because on the blade the part will be there and the part will have this dimension W. So, it will be 1.13 W. So, that the space on both sides could be 1.13 divided by 2, and the width here is 1.5 W and so on. So, this is a curve which is showing that parts delivered per blade depending on the L by W of the part. You can see that on an average the part delivery is quite low, in the sense that at a time there could not be let us say more than 1 or 2 parts. Okay, that is what the curve is showing. Well, the next feeder is the magnetic disc feeder, which is by the name itself it says that there are permanent magnets. First of all, there is a bowl here, this is stationary, this is the stationary hopper, and at the base of the hopper there are ferromagnetic parts of the ferromagnetic material, because they have to be stick to the permanent magnet which are actually located in each of these groups of this disc, and the disc is rotating perpendicular to this bowl feeder about this axis, and while rotating the permanent magnets which are there, they will actually stick the ferromagnetic material parts and they will raise them, and here there is a stripper, and this stripper will strip the parts and the parts will be delivered through the delivery chute. These are used for nuts, discs and square prisms particularly. This is quite a simple disc feeder and can only be used for parts of a ferromagnetic material. That is the only disadvantage, because we are using the permanent magnets here. So, therefore, parts are picked up by the magnets, and therefore, the parts have to be of the ferromagnetic material. On the basis of that magnetic disc feeder, we also have a magnetic elevating hopper feeder, where there are also permanent magnets on the elevator, and these slopes, these are actually guided by, or parts are protected by the ledges. This is the stationary plate here, and this stationary plate prevents the parts from sliding down, and when it is going up along with the parts will be located at the base of the stationary hopper, and while going through the stationary hopper and through the mass of the parts, these slots will be collecting the parts. Again, since it is a magnetic elevating hopper feeder, so there are permanent magnets in the ledges, and the parts again have to be of ferromagnetic material. So, the parts will be picked up in these ledges, in these grooves, and they will be stripped off at this when it is aligned to the delivery chute, and the parts will be coming down the delivery chute. This is also a simple device, but it is effectively used for raising the parts from one position, one level to another level. Here is another side view, where you can see the conveyor which is rotating constantly, and it is going through the mass of the parts. So, while going through the mass of the parts, the ferromagnetic material parts will be collected in these groups. They will be protected by the ledges here, and they will be protected by the stationary plate at the side, and these parts will be stripped off at this point, and it will go down the delivery chute. Well, the magnetic elevating hopper feeder is basically the same as the elevating hopper feeder, except that instead of ledges, permanent magnets are fitted to the endless belt, because we know that there are elevating hopper feeders, there the permanent magnets are not there. So, that is why it is called the magnetic elevating hopper feeder. Thus, the feeder is suitable only for handling ferromagnetic materials and cannot easily be used for orientation purposes, because it is permanent magnets there. So, they will be sticked there and it cannot be reoriented. This feeder is usually used to strip the parts from the magnets at the top of the belt conveyor. This is the belt conveyor, along which the parts are actually stick to the the magnets, permanent magnets. Now, our next topic we will be discussing on the part orientation, and earlier as I discussed, the parts have to be fed to the automatic assembly machines from the ball feeders in a right orientation. So, there have to be some kind of orienting devices, so that the parts could be fed to the right orientation in case the parts are not coming in the right orientation at the feeder at the ball feeder exit. So, basically to feed the parts to the workheads in correct orientation, there are two types of orienting devices. One which is called the in bowl tooling, and the other is called the out of bowl tooling. The name itself says that in bowl tooling types of the orienting devices, they can be used inside the ball feeder, and out of bowl tooling they can be used outside the ball feeder normally. So, the in bowl tooling part orienting devices, they can be of active or passive types. Active devices, they reorient the parts, and the passive devices, they reorient the parts by rejecting the parts, in the sense that if the part is coming in the right orientation, it will allow the part to go, but if it is in the wrong orientation, it will reject the parts and it will come back to the bottom of the bowl and it will again recirculate. Of course, when you are using the passive type, as you understand, since parts are going back to the bottom of the bowl, so it will be recirculating and there will be certain amount of wear and tear, because the parts are going round and round again and again. And out of bowl tooling, since this kind of orienting devices are placed outside the bowl, and outside the bowl we will discuss later on that this is on the feed tracks. That means, after the part has gone beyond the bowl feeder, there is a feed track which will take the parts to the machine after the bowl feeder. So, in the feed track, within the feed track, the out of bowl toolings will be located, and therefore, there is no scope for the parts to be rejected, because it cannot go to the bowl, it is already outside the bowl. So, therefore, only the active orienting devices are used out of bowl as out of bowl tooling, which will be located once again out of the bowl. So, outside the bowl. So, here is a diagram which shows different kind of part orienting devices. Let us say this one is a sector of a vibratory bowl feeder. Let us say that this is a part or a sector of a vibratory bowl feeder. This is the wall, and here is the track of the vibratory bowl feeder. So, as we discussed that any part located on the track of the vibratory bowl feeder will be moving in a short distance, it will hop, it will go forward and moving forward in a short straight path which will be inclined to the horizontal at an angle which will be more than the angle of inclination of the track. So, the track is spirally located inside the bowl wall. Now, first orienting device let us discuss, this is called the wiper blade. Okay. This, as you can see, the green one, this is the wiper blade. This wiper blade, as you can see, that depending on the space between the wiper blade and the track, it will allow the parts only when the distance between the wiper blade and the track is sufficient for the part to go forward. For example, suppose we have the parts like shown here, it is the headed parts, okay, and when the headed part will come in this orientation, the part will not be allowed to go through and the wiper blade will reject. So, therefore, in this case the wiper blade is a passive device, it cannot reorient the part, but it will actually reject the parts because it is coming in the wrong orientation. Let us say our desired orientation is this, when the parts are coming with the head up. So, to take the parts, to take all the parts with the head up, this kind of orientation is not suitable. So, it will be rejected, it will go to the bottom of the bowl, to the base of the bowl, and it will again be recirculated. Now, the parts which are coming in this orientation, that is with the head ahead or with the shank ahead like this here shown. So, they will be allowed to pass through the wiper blade, because the space here between the wiper blade and the base, the track, this is sufficient for the head to pass through, but it is not sufficient for the whole length of the part to pass through. So, therefore, the parts with the orientation, this kind of an orientation, that is with the head ahead or with the shank ahead, will only go through. What we want after this is that the parts which will be going further after that can be only in this orientation. Suppose there are parts which are coming without the, if there is no wiper blade, suppose, so then the parts will be coming in this orientation and it will come here, but there is a pressure brake. This is another orienting device which is mounted at the wall of the vibratory bowl feeder, and you can see the shape, this is protruded and this is called the pressure brake. So, the pressure brake, what it does is limits the distance in this here, so that within that distance the parts which are coming in this orientation will not be allowed to go further. Okay. So, even if the parts are coming in this orientation without having a wiper blade, for example, in the bowl feeder, then these oriented parts will actually fall down. So, here it is written, screws rejected unless in single file end to end, or if delivery chute is full, for example. So, what does it mean? So, in this case what we are saying is that if the delivery chute is filled up, delivery chute, you understand that where the parts are going after the bowl feeder, in that case the parts cannot go in further. So, there is a pressure here from the parts which are located further, and it will not allow those parts will, since they are in a single file, these parts will not allow the parts coming in this way from here, and those parts will fall here. And the pressure brake, as I said, that pressure brake will not allow these kind of parts to go through. Next, So, therefore, the pressure brake here, which is actually allowing the parts in this orientation or in this orientation, this is also called as a passive device, because it is not reorienting, it is actually rejecting the parts. All right. After this, here as you can see on the track, there is a slot here, okay, and there is a slope. This is sloped here. So, the parts which are coming in this orientation with the shank ahead, these parts will go further and dip into this slot, and it will hang with the head up. So, it will go through the ball feeder. Or if the parts are coming in this orientation with the head ahead, it will go little further and then it will dip, the shank will dip inside this slot, and again the parts will be moved with the head up and it will be hanging. So, these three orienting devices which are shown here, these are popularly used also, and out of that you can say that this slot is an active device, because in this slot actually nothing is rejected, parts are reoriented, meaning that if the part is coming in this orientation or in this orientation, one of these orientations, both can actually go in. So, it is reorienting the parts, and the part right or the desired orientation is this orientation. So, all the parts coming after the ball feeder, with using these three part orienting devices, we can ensure that all parts will be coming with this orientation, which is the desired orientation for us. Well, next is another part orienting device. These are the examples. I am going to give you some examples which are used for different kind of parts, when the part shapes are very different. For example, here is an example of orienting device where which we are using for the for such kind of parts, which are washers. Okay. Now, these are commonly employed for washers, like suppose if it is the ball valve, again this is a sector of a vibratory ball feeder, and the parts are moving because of the electromagnet and the suspension spring. So, when the parts are located on the track of this ball feeder, so then it will come here, and then here there is a slope, all right, and because of the slope the parts will be coming and they will be protected by the ledge of this wall. But if the washers are coming with the in the standing position, that is on the sides, they will actually be rejected, because this ledge or this edge is not sufficient to hold the parts. So, therefore, those parts will be coming down. Washers not lying flat on track fall into ball. So, they will go back, those kind of parts with those orientations which are not lying flat on the track, they will fall back to the ball bottom, and then again they will be circulated, and then again will be coming, and if they are coming in the right orientation, then only they will be able to go through. So, this kind of a ledge and the slope which is given on the track is also a passive device, because they are not also reorienting the parts. Okay. The next one is orienting device, and here a new orienting device which is shown here. This is the scallop. Okay. So, again let us say this is a track, this is a track, and this is the ball feeder wall, and this is the sector of a vibratory ball feeder. Now, through this we have to take the parts, we have to feed the parts of this kind of a parts. Okay. And this device makes use of the difference in shape between the top and the base of the part to be fed. So, the part is like this, here we have a central hole, and this is a blind hole. So, that this part is the heavier part and this part is the top portion is the lighter part. So, let us say that all the parts are coming in different orientations. The orientations could be this, or the head up, or the open side down, okay, the open side up, the side or the open side to the left, or it can be the open side to the right. So, these are the four basic orientations that these parts can have, and in any of these orientations the parts will be coming in the beginning. So, the wiper blade, we have arranged one wiper blade here which is mounted at an acute angle to the wall. I will remind you, because otherwise what will happen, there is a chance of the thin parts to be jammed under this wiper blade. So, therefore, the wiper blades are mounted on the wall of the feeder at an acute angle normally. So, through this wiper blade, the parts which are not lying on the track with the head with the heavy side down or heavy side up, like for example, in this orientation, they will not be allowed through the wiper blade, because this distance again is not enough. So, all other parts which are lying like this or like this, they will be able to negotiate this path and they will come here, because these kind of parts will not be able to negotiate the space given between the wiper blade and the track. So, after the wiper blade, all the parts which are getting will be either the heavy side down or with the heavy side up. Now, our desired orientation, let us say this is the heavy side down. So, we want all the parts to come out of the ball feeder with the heavier side down. So, therefore, all the parts which are coming with the heavier side up, they have to be rejected or reoriented. Here there is a scallop. So, depending on the inner diameter of the part, the scallop is made in such a way, scallop is simply a cutout. So, this cutout is made in such a way that if the parts are coming with the heavier side up or the open side down, this will not be able to negotiate this space, and they will be rejected. So, these scallops, this kind of orienting device is also a passive device, and they will actually be they will reject the parts rather than reorienting that. I would like to tell you that in most of the cases, the orienting devices are normally passive devices, because they are simple and they are easy to make, as you can see, and there are few only which are active devices and which are used basically in the out of bowl tooling. So, therefore, all the parts which will be coming after the scallop will be of this orientation, which is the desired orientation, that is the heavy side down, and we will get these parts to the delivery chute. Through the delivery chute, we will get those parts which are of heavy side down. Okay. So, that is the idea of such kind of orienting devices. Next, let us say the orienting device here, which is a cutout, which is quite similar to the scallop, but here what we use this for is for a part where the diameter at the bottom or diameter at the top and the diameter at the bottom, they are quite different. Okay. So, they are conical in shape like this, as it is shown here. So, through the track, when the parts are coming, these parts will be coming either with the bigger diameter down or with the bigger diameter up. Now, since the diameter here is smaller for this, so then all the parts which are with the higher diameter or the bigger diameter down, they will be able to go through the cutout, V cutout, because they will be able to negotiate this space. This space is designed in such a way, this V cutout is designed in such a way that the bigger diameter would be able to negotiate, whereas the smaller diameter will not be. So, if the our desired orientation is this, that is all the parts should be in the delivery tube with the bigger diameter down, in that case all the parts will be rejected in this V cutout, because the smaller diameter will not be able to negotiate this part. They will be unstable and they will fall from the track, it will go again to the bottom of the bowl, it will be recirculated and again it will be coming, and if they are coming in the right orientation, that is with the higher bigger diameter down, they will be able to go through. That is the idea. Now, next orienting device is used for U-shaped parts, okay, and this kind of an orienting device can be designed. Let us say again, this is in the vibratory ball feeder, this is the bowl wall, and this is the feed track. Okay, sorry, this is the track of the ball feeder. Now, there is a wiper blade here. So, the all parts which are coming not flat either with the closed side ahead or with the closed side back, they will not be able to go through the wiper blade, because this space is not enough for the parts like this in this orientation when they are coming standing like this, all right. So, these parts will be rejected by the wiper blade, and all the parts with the closed side ahead or the closed side at the back will go through. Then these parts, when they are coming through the wiper blade, they will be able to ride on the rail, as you can see this here. This is quite self explanatory, and they will be coming through the rail, and here there is a protection, so that the parts will not parts do not fall, and they are coming to the delivery chute, and this is the right orientation. Let us say this is the desired orientation. So, all the parts which will be coming through the rail, we can ensure that they will be of this desired orientation. So, this is the idea, that parts are rejected until they climb into the rail. So, all parts climbing into the rail, we are ensuring that way that they will be coming to the delivery chute in the right orientation. So, through these examples, what I am trying to show once again is that the orienting devices can be designed depending on the part, because these are only some samples of the parts. Parts can be very different. Now, if an engineer or a specialist working in the industry has enough experience on these kind of devices, orienting devices. So, if a new part comes with a new shape or a different shape, so you can actually design an orienting device based on the type and the shape, size of the parts. This is not a big deal, this is not very difficult, as you can see, and I will show you some other examples as well, other examples of the orienting devices as well, depending on the type of the parts, the shape of the parts, and so on. Thank you.